All right, so the lab's really just going to be doing some calculations either on the distance you could place a mass relative to a pivot point, or what amount of mass you could hang relative to the pivot point. If we were doing the lab itself, we would have these different setups where you'd manually hang. So here we have an example of, the center mass of the actual board's roughly at the center of the ruler, so it's sitting at the middle there. So that means the only two things contributing to the torque are a weight on one side and the weight on the other side. And as you can see here, given that it's a 1 meter stick, they're two identical masses of 200 grams, and by putting them at the same space, in this case 40 centimeters on one side, 40 centimeters on the other side, we expect that the two even masses are going to cancel each other out in terms of their torques, and the system ain't going to rotate anywhere. Alternatively, we can, we set up the system now, we actually have to care about the center of mass of the board itself, of the stick itself. So the whole stick, has some mass to it that's basically creating a torque that we say, that weight of this is acting down here at this point. We got this mass over here that's pulling down, and it's pulling down this distance away from the pivot point. And then over here, to counterbalance, we add a mass that has to be this distance away. So the torque thanks to this, and the torque thanks to the weight of the stick, and the torque thanks to the little mass over here. Those counterclockwise torques cancel out these clockwise torque, and since they cancel out, the system doesn't rotate. Here, just to show a more extreme case of this, now we don't have to even hang a little mass over here. Here, literally, the center of mass of the larger stick is enough to balance this out. So over here, we have this amount of mass, this distance away from the pivot points causing clockwise torque. Then over here somewhere, it's not on the meter side, whatever half of 78 is. Somewhere in the middle here, where the center of mass is, that certain distance away, then that's the weight of the entire stick is giving rise to the counterclockwise torque, and that counterclockwise torque and that clockwise torque cancel out. Again, the system's in rotational equilibrium. Okay. And so you can imagine, there's many potential ways. We'd hang a bunch of different weights, set them at different distances, and the formulas for summing up the forces and summing up the torques would still have to hold. And so that means we can create a formula to solve for a vast number of configurations of masses and the locations they're placed at. All right, so just in the lab, expect to do, there'll be some calculations. You'll basically see little diagrams. It'll be like a little picture of, like this setup with the masses labeled, the distances labeled. And you'll just have to calculate, like if this mass is this far away and we hang a certain mass, then how far away could the other mass be? Assuming we also know where the center of mass of this plank is and all that. But you'll see in the lab document itself.